Hello everyone, and good evening. My name is Austin Taylor, and today I'm going to talk to you about my research project for this class, which was on the deep web. In this presentation, I will be going over a brief history of the internet, an explanation of what the deep web is, and what has already been done with the deep web, and finally conclude with my references. Let's begin with some brief history of the internet. The late 1960s marks the day of the world's first workable internet prototype, called Advanced Research Projects Agency Network, ARPANET. ARPANET allowed multiple computers to communicate on a single network through the use of packet switching. In the following years, technology continued to increase, and in the 1970s, TCP/IP was created, which was a new communication model created by two scientists, Robert Kahn and Vinton Cerf. TCP/IP is the current standard for transmitting data between multiple networks. In 1983, ARPANET adopted TCP/IP, and researchers started to construct the network of networks, which eventually became our modern internet. By 1990, the World Wide Web was created and has become the most popular form of accessing the internet today. After the creation of the World Wide Web, internet browsers were soon created to help people surf the web. The first browser was created in 1992 called Lynx, which was a text-based browser and could not display any graphical content. Within a year, Lynx was replaced by newer browsers and more popular ones, Mosaic and Netscape Navigator, that were capable of displaying graphics. A year after that, Microsoft developed its first internet browser called Internet Explorer. From 1995 onward, the internet continued to grow with the creation of more browsers, search engines, social media sites, and many other websites were created, which we commonly use in our everyday lives. But how do search engines like Google find all these websites that provide us with our much needed information? Do they hire these super sleuths to track down and hunt down companies' websites to make their search engines better and gain more web traffic? No, companies do not hire super sleuths to hunt down websites to make their search engines better. Companies like Google actually use web crawlers, also known as spiders, to build their search engines. The job of a web crawler is to go out onto the World Wide Web from seeded web pages and systematically download a web page and index that web page, and then add its content to the search engine to update its web content. Web crawlers don't stop there, however. If a web page that it has downloaded has links to other web pages, it branches outward and goes onto those web pages and downloads those. And then it repeats the whole process over and over again, helping to create bigger and better search engines. Since the 1960s, the internet has gotten so big that the combined total of just Google, Amazon, Microsoft, and Facebook amounts to an estimated 1,200 petabytes of data on the internet. With all this vast amounts of data on the internet, it seems almost endless the amount of knowledge and information that is right at our fingertips. We see the internet as this huge and wondrous place with only a few things out of reach. However, even with all the vastness of the information available on the internet that we use on a daily basis, we are barely even scratching the surface. The amount of internet that we are accustomed to searching on is known as the surface web or clear web, and it only amounts to 3 to 4% of the information on the internet. The other 94 to 95% of the information that is on the internet resides on what is known as the deep web. The final 1 to 2% of the information on the internet resides on the dark web. The surface web is the visible and indexed portion of the web which a typical search engine is able to find. The surface web includes things like blogs, shopping, news sites, and social media, basically anything you can find on Google. The deep web, however, is content hidden behind HTML forms and is the unindexed portion of the internet. Personal email accounts, banking accounts, medical records, confidential company websites, and websites that require registration and login are examples of the unindexed information that resides on the deep web. The reason this kind of information on the internet is not indexed and available on the surface web is because it contains information you do not want someone to be able to find on a typical search engine. The dark web is the internet content that resides on darknets, which are overlay networks that require specific software or browser configurations and authorizations to access. The dark web allows people to conduct business anonymously without giving any identifiable information. The deep web and dark web are often confused as interchangeable terms. However, these terms should not be confused as interchangeable. While both the deep web and the dark web contain unindexed web content, the dark web is just a very small subset of the deep web, which can be accessed through special browsers like Tor. And the dark web usually contains more shady and illegal activity than the deep web. Now that we know what the deep web is, let's discuss what has already been done with it. The deep web derives its name from the fact that its content was thought to be beyond the reach of search engines and has presented to be a long-standing challenge in the field of information retrieval. While content of the deep web is hidden, it is not inaccessible. In a paper titled Google's Web Crawler, the authors found that content on the deep web can be accessed through form submissions with valid input values. The paper also discusses how the deep web can be accessed and how the deep web can be more easily searched. The two common approaches to accessing deep web content is through a data integration solution and surfacing. Data integration solution is the creation of vertical search engines for specific domains, such as books, real estate, or cars. Using this approach, a mediator form can be created for each domain and semantic mapping for individual sources of data and the mediator form. However, this approach has drawbacks. There is a high cost in maintaining the mediator forms and mappings, and it is challenging to identify which query is relevant to each domain. Using the surfacing approach, it pre-computes which HTML forms are the most relevant form submissions and the resulting URLs are indexed. This approach allows existing search engine infrastructure to be utilized, making the inclusion of deep web pages more seamless. The former was the approach the authors took when searching the deep web. The two issues the authors faced was deciding which input forms to fill when submitting queries to forms and what values would be appropriate to fill the inputs. The HTML forms they chose to search were GET forms, as the URLs obtained from GET forms are unique and are usually suitable for indexing. The key contributions that they made to the deep web searching was informativeness tests, an algorithm that evaluated which query templates was suitable for surfacing, and an algorithm that predicted appropriate input values for text boxes. The informativeness tests were used to evaluate query templates to select appropriate combination of form inputs. A template was considered informative if it generated pages that were sufficiently distinct, and a signature was computed for content of the resulting web pages from each form submission. Templates were considered uninformative if they computed much fewer signatures than the number of possible submissions. The algorithms the author created was called ISIT and was used to evaluate which query template was suitable for surfacing by going over the space of the query templates. This image shows a snippet of the code that they used for the algorithm. The ISIT algorithm searches through the space of the templates in a bottom-up fashion, starting with single binding input templates. Starting from dimension 1 candidate templates, the getCandidateInputs method selects inputs to be considered, which are select menus and text boxes. Any other inputs are set to default values. Then the checkInformative method tests the candidate templates for informativeness. Any of the dimension 1 templates that are considered informative go through the augment method that constructs candidates for dimension 2. Each of the new candidate templates are then tested for informativeness and proceed in a similar fashion to create candidate templates for dimension 3. The algorithm is terminated when there are no informative templates of a given dimension. Through their informativeness test and algorithms the authors used to access deep web content, they were able to show how the deep web can be accessed and more easily searched, resulting in content that covered over 700 domains, 50 languages, and millions of forms that users are able to enjoy every day. In another study of the deep web called Truth Finding on the Deep Web, Is the Problem Solved?, the authors sought out to search the deep web and study how accurate and truthful the information on the deep web is, and also assess its quality. They focused on two domains of the deep web data that they believed were fairly clean, which was stock data and flight data. Through the use of crawling queries, they were able to return 55 usable sources from the deep web for the stock domain and 38 usable sources from the deep web for the flight domain. The authors tested the quality of the deep web data by assessing the data's redundancy, consistency, accuracy, and where data was copied among the sources. The data collected from the deep web can vary greatly from different sources, and a lot of conflicts can arise because of it. To help resolve these conflicts and find true values, the authors used data fusion, which is a strategy that considers the dominant value as true and works well when the percentage of dominant values is large among the sources. What the authors observed in their study was that the inconsistency of data from the sources was high and the quality of the data was quite low. They observed a 66% redundancy for the stock data and a 32% for the flight data. Accuracy also varied among the sources, and there was copying among the sources as well. And while data fusion methods have good potential for resolving value conflicts and finding the truth, they are not perfect and there are still areas that need to be improved. Here is a YouTube video of how these two guys went exploring on the deep web, which I won't be playing in this presentation to keep within the time constraints. But in the video, they used the Tor browser in combination with a special operating system called the Amnesic Incognito Live System, also known as Tails, which is a Linux-based operating system that doesn't leave a footprint on your device. In the video, the guys go to a .onion website that has a directory of deep web and dark web content. I would encourage everyone in their spare time to check out the video, as it shows how people have already created ways to more easily access deep web content. The internet is a vast and wondrous place filled with information, and while we only use a very small portion of it in our daily lives, it provides us with great opportunities to learn and discover more about what the internet has to offer. Studies such as Google's Deep Web Crawler and Finding the Truth on the Deep Web, and as well as others, show us what we can learn about the deep web and provide us with a greater knowledge of how the internet really works and what it contains. Here is a list of my references that I used when I researched my project. I hope you enjoyed my presentation and thank you for listening.